Okay, this is June 2007, Module 4, Question 5. And question starting here will state the purpose of the constant epsilon naught and the law for the force between 2-point charges. Now the purpose of this is to ensure the units are correct either side of the equation, and that has come up before, so it's important that we remember that. So to ensure that the units are correct for each side of the equation, or to ensure that the units balance on each side of the equation, the units on the left hand side are this equivalent to the units on the right hand side. Right, so we now have a point charge of +2 microcoulombs is subjected simultaneously to two electric fields, E1 and E2. E1 is a vertical field 6 volts per meter, and E2 is a horizontal field of magnitude 4.5 volts per meter. So we're asked to calculate the resultant force on the point charge and find its direction relative to the horizontal. So what we have to do is say, well, this is E1, so that's the force due to E1, and this is E2, so that's the force due to E2, and this will be the resultant force. Alright, oops, sorry. So force due to E1, the force due to E2, and the resultant force. If we consider what the force due to E1 is, well, what we're saying there is that E is equal to force per unit charge, therefore the force is equal to E times Q. So we have 2 times 10 to the minus 6 times 6 for, this is the force due to E1, will be equal to that, which is equal to 12 times 10 to the minus 6 newtons. And then the force due to E2 is going to be equal to, well, that was 2 times 10 to the minus 6 times 4.5, which turns out to be 9 times 10 to the minus 6 newtons. And so we now have a situation where we have 12 acting there and we have 9 acting there, and we're trying to find the resultant. So we're going to say F squared is equal to 12 squared plus 9 squared, therefore F is going to be equal to the square root of that, and that turns out to be 15, and remember it was times 10 to the minus 6 whenever I've just dropped the 10 to the minus 6 there for that calculation, so 15 times 10 to the minus 6 newtons. So the resultant force is equal to 15 times 10 to the minus 6 newtons. The direction of that force, well, we're looking for the direction compared to the horizontal, remember, so we're going to say for this one here, if we consider here, that's the angle that we're looking for there, so tan theta is equal to the opposite over the adjacent, so tan theta is equal to 12 over 9, so that means that theta is equal to the inverse tan of that 12 over 9, and that means that theta is equal to 53 degrees. So the direction of the force is 53 degrees to the horizontal. Okay, a bit of calculation going on there to get to that. 4 marks, 1 mark, so you just need to take your time and work through that. First thing we did was we worked out what the force was, 12 times 10 to the minus 6 vertically, 9 times 10 to the minus 6 horizontally, so we had 9 horizontal and 12 vertical. That means if we use Pythagoras, we get F squared equal to 12 squared plus 9 squared, or F is equal to the square root of those two added together, which when we square root that we get 15, but I've omitted the 10 to the minus 6 because it was easier to work with. Therefore it's 15 times 10 to the minus 6 is the force. Then we use tan to work out the angle, 53 degrees to the horizontal. Okay. Another calculation, this again, this is quite a tricky calculation. Okay, so we've got 3-point charges on a straight line. The magnitude of the charges and their separations are shown. So the two outer charges are both positive, and x is an unknown charge. So this is 25 microcoulombs, 2 microcoulombs separated by 10 meters, and x is 4 meters from the 25. The resultant force on the 2 microcoulombs charge is 3 times 10 to the minus 3 to the right. Find the sign and magnitude of the charge x. Alright, so this is going to take us a little bit of working out here, just whatever's going on. But first of all, we're going to work out what force acts on the 2 microcoulombs due to the 25 microcoulombs. So this is the force that is acting. Okay. We're going to work out the force that's acting between the 25 microcoulombs and the 2 microcoulombs, and that's equal to, well, K times Q1 Q2 over R squared. So that's equal to 9 times 10 to the power of 9 times Q1, which is 25, times 10 to the minus 6. I'll write that as 25. 25 times 10 to the minus 6 times 2 times 10 to the minus 6 all over, and it was 10 meters separation for those two, all over 10 squared. And that gives us then a force of 4.5 times 10 to the minus 3 newtons. Okay. Now, if we go back and look at the question, we're told that the resultant force on that charge is 3 times 10 to the minus 3. Now, if we take a look at the question here, what we're seeing is 25 microcoulombs is pushing against that because they're both positive, so 25 microcoulombs is pushing against that with a force there of 4.5 times 10 to the minus 3 newtons. And we're told that, okay, if we look in the question, we have 3 times 10 to the minus 3 to the right as the resultant force. That means that x, okay, x must provide a difference there of 2.5 times 10 to the minus 3. Okay, if the resultant force is 3, there must be, sorry, 4.5, if the resultant force is 3, there must be 1.5 times 10 to the minus 3 to the left. Okay, so 1.5 times 10 to the minus 3 newtons must be acting to the left due to x. Okay, so x causes a 1.5 times 10 to the minus 3 newton force acting to the left, which means that we can say first of all that x is negative. Okay, why is x negative? Well, because in order for that to produce a force to the left, then x must be negative, attracting that positive charge towards it. What's the magnitude of that going to be? Well, we have 1.5 times 10 to the minus 3 has to be equal to k, which is 9 times 10 to the power of 9, times the 2 microcoulombs, so 2 times 10 to the minus 6, times the charge that we're looking for, divided by, and the distance between those two. Well, if we go back up and check the distance between x and here is 6 meters, so that's all over 6 squared. Therefore Q is equal to 1.5 times 10 to the minus 3 times 6 squared divided by 9 times 10 to the power of 9 times 2 times 10 to the minus 6, which gives us a total of 3 times 10 to the minus 6, so that's 3 microcoulombs. Quite a difficult question there, but if you just follow through and keep your wits about you, it's not impossible.